Problem 14. Here we have f, a force F acts on an object. We have F equals to 4xi plus 3y j Newton acts on an object as the object moves in the x direction. Here we have x, the object here, and here we have F applied on the object. You see here that the x component, here we have x equals to 5 meter. So the object moves in the x direction from the origin to x equals to 5. Okay, you see here, let's say we have the origin here, y and x. Here we have the position x equals to 5. The object will move from the origin O to x equals to 5. So here we have the displacement delta x equals to 5. Okay, if you want to put the direction, we have 5i meter. Okay, the question is we have to find the work of F. You know, because F is not constant, the work of F equals to integral F dot dr. Okay, this is the general equation of the work. We have to find the work done on the object by this force. Okay, you know, in general, you have to write this relation. We have to move from the initial position to the final position. Okay, it's in function of the distance. You know, here we have a displacement in terms of x. dr equals dx plus dy. Here we don't have a displacement in terms of y, just on the x-axis. Okay, look here on the x direction. So we don't have dy. We can write directly dr equal dx. So the work done equals to the integral of f dot dx. We can substitute the value of f here. We get equals to, okay, the x-axis, dx here, dx is between 0 and 5. Equals, we put the value of f, we have 4xi plus 3yg. Okay, Newton times dx. Here we have dx. Now we have ij. We keep the vector here. Be careful. You have to keep the vector of dx. You can write dx, or you can write dxi. You cannot write without I and j, because here you have I, j, I. We have the direction in the formula. You have to keep writing the direction. And the limit will be between 0 and 5. We continue here. You know, here you have integral of 0, 5 for 4xi times this term and this one times the same term. We simplify the parentheses. We have 4x times 4xi times dxi. We get 4x dx, 4x dx, and I dot I. Okay, plus the integral between 0 and 5, 3yj times dxi. So we get 3y dx, and we have j times I as a vector. Okay, here be careful. In general, you have x and I. In I will be in the direction of x-axis, and j in the y-axis. The angle between I and j equals to 90. Okay, so I dot I equals to I times I times cosine the angle between them. I and I, the angle between I and I equals to 0. So cosine 0. Here we get 1 times 1 times 1. Why? Because the magnitude of I equals to 1. The magnitude of I equals to 1 and cosine 0 equals to 1. Okay? This one, like A dot B equals to A dot B times cosine the angle between A and B. Okay? Here we have I. Always the magnitude of I equals to the magnitude of J equals to 1. They have the same magnitude. Okay? Now, I dot J equals the magnitude of I times the magnitude of J times the angle between I and J. The angle between I and J equals to 90. Cosine 90 equals to 0. So I dot J equals to 0. It's important, this point, okay? So here, you know, I dot J or J dot I, you get the same value because J dot I equals to J I cosine 90. Cosine 90 equal to 0, so J dot I equals to 0. Okay, we can say this one equals to 0. We have only the left one. I dot I equals to 1. So this one equals to 1. We get integral of between 0 and 5 for x dx. The integral of x dx equals to x squared over 2. So here we have integral 0, 5, 4x dx equals to 4x squared divided by 2 between 0 and 5 equals to 4 over 2 equals to 2. So we have 2, 5 square minus 0 square. We get 5 square equal 25. 25 times 2, 50. We have 50 joule. So this is the work done by this quantity of F on the object. Okay? Thank you.